Hey everybody, Peter here. So I'm doing my first of math videos for this summer. This is the one for June 1st. So today I'm going to look at multi-digit multiplication, but I want to look at it two different ways because there's one way that a lot of people are trained to do it, but then there's another way that I think is really helpful. So let's start with the algorithm that a lot of you probably learned in school, at least if you're of a certain age, like me, which is just to kind of write the top number and the bottom number and to multiply these out. Now this is pretty algorithmic, and there are a couple different ways you could do it. I'm going to show you my preferred method. Now, full disclosure, I haven't actually done this in like years because I don't like doing it this way, and I'm going to show you the way that I prefer to do multiplication that actually translates into algebraic multiplication as well. I'll show you that after this, immediately after this. So the way I could do this is I start with the 6 and I'm multiplying 327 by 6, so 1 by 1. So I'm going to take the 7 multiplied by 6, I get 42. So I'll write down the 2, carry the 4. Now I do 2 times 6, I get 12. Add the 4, that's 16. So I write the 6 down, carry the 1. 3 times 6 is 18, plus the 1 gives me 19. I carry out that last digit. Now I'm going to do this again in red for the 5. So what I do is 7 times 5, except it's actually 7 times 50. So what I'm going to do to help with this is I'm going to write a 0 at the end. Okay, and that just is kind of taking the ones place because we're not multiplying 5 by 7, we're multiplying the 50 by 7. We'll talk more about why I don't like this in a second. So we're doing 50 by 7, that should give us 35. 5 out front. Now instead of a 4, we have a 3 carried on the 2. So 5 times, well, really 50 times 2, that would be 10 here, so plus the 3. So we'll write down a 3 and carry the 1. And if we do 3 times 5, that is 15, plus the 1, that is 16. So we get that. Now what we have to do is actually add these together. I'm going to switch back to blue here. So here we can just go column by column. So this part's pretty easy. We go 2. 6 plus 5 is 11, so we'll carry the 1. 10 plus 3 is 13. We'll carry the 1 again. That gives us 2 plus 6 is 8. And we have that 18 out front there. So if we multiply 327 by 56, we get 18,312. Now, this method is not bad. This is the way a lot of people were taught. I want to show you another method to kind of call this the area method. And it's going to look a lot like finding area. So let me talk about that real quick. Right here, we have a rectangle. Now, if you were to find the area of this rectangle, you would multiply length times width, which is exactly what we're going to set up here. So what we're going to do is take that same 327 and break it up. We're going to do 320 and 7 across the top, and across the left side, we're going to do 50 and 6. So what we have done is we've taken the length of the rectangle, 327, and broken it into 3 pieces. And then on the other way, we've broken the 56 into 50 and 6. So what we're going to do now is multiply and find the area of each of the segments of the rectangle. And then we're going to use those to find the area of the whole rectangle. Now, one of the reasons I like this approach, just before I get into it, is you're doing a lot of the same multiplication steps that we were doing over in the other problem. But here, it's a little less kind of tricky, like, oh, I carry that and then I add that for some reason. And I think it'll make more sense how some of this multiplication stuff works. So let's get into it. I'm going to write in blue, looking at the top row. So I'm going to start with the hardest one, which is 300 times 50. Now I have 100 and I have a 10, so I know that I'm putting 0, 0, 0 at the end there. And then I have 3 times 5, well, that's 15. So just to recap how I got there. I know that 3 times 5 alone would be 15. 3 times 50 would be 150. 30 times 50 would be 1,500. And 300 times 50 is then 15,000. So what you notice is that if you have more zeros at the end of the number, you simply add those on at the end when you're done. So 3 times 5 is 15, and then 0 from the 50, and then 0, 0 from the 300. So what we're doing is kind of adding back these places that were in there originally. Okay, And I think all of that is easier than like trying to do the multi-digit stuff where you're adding other numbers in. This is pretty clear. So next up, we have 50 times 20. So we're going to have 2 zeros at the end. I know that already. But now if I multiply 5 by 2, it is 10. So my product there is 1,000. Looking at this last box, this is probably the easiest one in this row. So we have 7 times 50. 7 times 5, that's 35. And then we have to add the 0 in because we were multiplying by 50, not just multiplying by 5. So there's our top row. We're going to look at the bottom row now in red, and we're doing roughly the same thing. So we have 300 times 6. Well, 3 times 6 would be 18. So 300 times 6 would be 1,800. Next, we have 20 times 6. Well, 2 times 6 would be 12. So 20 times 6 is 120. I just added, multiplied by 10 there. And then this last one, 7 times 6, well, that's 42. Okay. So I want to just stress, like, none of the math we just did was very hard. Really, the hardest thing was knowing, like, okay, what's 7 times 6? What's 7 times 5? What's 2 times 5? Kind of those easy multiplication facts that most of you probably have down, even if you don't have bigger numbers down. So let's move into the next component of what we would have to do here. At this point, you need to add all these numbers up. So we need to add the area of each thing, each of these segments. So we have 15,000, we have 1,000, we have, I'm actually going to write the 1,800 next. There's no particular reason that I'm writing these in blue or red. Then we have 350, and the order does not matter here. I'll talk about that in a second as well. 120, and finally 42. The reason I wrote these in this order is mostly so that they're not all decreasing, but they're mostly decreasing as we go down. And that'll just make it a little easier for me to keep track of like what we've added and what we haven't. And I think it'll be easier for you to follow as I start tallying these up. So if I look down the first column, this is the ones. I have a bunch of zeros and then a 2. So, oops. Let me write that. And we have a 2 there. So if I look in the next column, I see 5, the 50, the 20, and the 40. So 50 and 40 is 90 plus 20. Oh, that's 110. So what I'm going to do here is carry the 1. And we're adding. So I'll just put that up there. So 110, we write it 1 in the tens place, representing that 10. And then we have this other 100 that we're going to add to the other hundreds. So I see an 800, a 300, a 100, and we have that extra 100 that we're adding in. So this gives 1,300, right? So we can write down the 300. We have to carry the 1,000, put it with the other thousands. So now we've got 6 plus 1 plus 1 is 8,000 and 1. And you can see this is the same answer we got over here. Now, some of you are going to look at this and say, yeah, it's more work. Which arguably it is. You have to draw a rectangle for the setup. Well, you don't really have to. And you have to add everything up at the end rather than adding up 2 numbers. Here are the reasons that I like this method though. First of all, fewer chances to make mistakes, because even though you're doing more work, the work you're doing along the way is easier. Meaning you're not doing all this stuff with carrying all the time. You're just doing a simple multiplication, pause, a simple multiplication, pause, a simple multiplication, etc. So this is something that they're teaching in a lot of schools. And I really like the fact that they're doing it. I think it's with Common Core, you start including area method along with traditional multiplication algorithms. I want to show you something else as a point to why this is so helpful. So let's set up another rectangle. And this time we're going to do actually a polynomial multiplication problem. So we're going to do x squared plus 3x plus 5. And then on the other side, we'll do x plus 3. Now this is more of an algebra problem, right? So, but the nice thing is, if you have learned this the area method way, which you have if you saw it in multiplication, you can now do this polynomial multiplication super easily. So if we go across, we're looking at this top left here. Here we're doing x squared times x. Well, that's x cubed. And then the next box over, we have 3x times x. Well, that's 3x squared. And in the final box, we have 5 times x. On the bottom row, we've got x squared times 3, so that's 3x squared. We've got 3x times 3, so that's 9x. And in the last square, we've got 15, 3 times 5. So this is pretty easy. You can also clean up really nicely. I'll show you real quick. You can add the x squareds and you can add the x's. I know that's a little more algebra than you were probably expecting out of a video on just multiplication, but it works. So if we add these together, you get x cubed plus there's 3x squared and 3x squared. So that's 6x squared plus 14x plus 15. Okay, so that is a way to multiply polynomials that uses this same area method that also works for multiplying two numbers. You don't have to learn separate algorithms for each of them. You just have to learn the one, and then you are all set to multiply sort of any number of things that you can break up. And you're also going to be really good at finding the area of a rectangle by the end of all this. So again, this was, I guess this is Math Mondays since we did, or Multiplication Mondays. Probably not multiplication because I don't want to be multiplying all summer. But this was my first video, and it was on the area method in multiplication of both numbers and some algebra stuff. So I hope you enjoyed, and I'll see you tomorrow.